Okay, you all know me. I know you, so we're just gonna go. Skip all that introduction stuff. As you can see on the front page of World Class, I want to do things differently now. We've been talking back and forth for several semesters about how to integrate AI into our classes. We know it's got to happen, and nobody really knows how to do it. So I'm going to kind of take the plunge and be one of the first here to try to do something. Dr. Hart has got his own way of doing it, and I'm going to do something a little different just so we can compare notes later. What I really want is for the AI to be a collaborator in our work. In other words, like the pair programming idea where the AI is the pair that's not at the keyboard, right? I think that's the most productive way to use it, and in such a way that you'll still learn from it. Because at the end of the day, you still have to go in and do your interview without the AI assistant. So you still have to know how to write the code, you still have to know how to read the code. And you have to know how to evaluate what the AI is telling you, whether it's right or not. As well as other design considerations, et cetera, et cetera. So that's the first part of the announcements. Well, actually, the second part, I guess. The first part is this Marimo notebooks. These things are really kind of cool. They're a little bit different from a Jupyter notebook. They serve the same sort of purpose where they have markdown and code, but they are reactive. In other words, when you change one cell, it updates all the others with the new value or change, whatever. And so you never have to worry about, I made a change down here, so does that affect up there? And what happens if I run it straight through? You don't have to worry about any of that anymore. Plus, it also has a better set of widgets than Jupyter does, so it's a lot easier to build dashboards and things like that out of it. I've had my eye on it for a while, but I haven't wanted to use it, so we'll see how it goes. I'm hoping that everybody will kind of be in this with me and help me figure out how to make it all work. Meaning I don't know how it's going to work yet. We all need to be a little bit flexible. That being said, I'm assuming that everybody needs at least some amount of guidance for these Marimo notebooks. And so if you go to their website and you go to Docs, you can see there's an install with Conda. And this is of course, if you are using Anaconda. So you can copy that. Now, here's where it gets really fun. Everybody should know how to get to their terminal window. And if you are on Windows, you need the Anaconda terminal window, which you can get to from the start button, doing a search, and start typing Anaconda, and it should come up. For those of us that are lucky enough to be on Mac, you don't have to do that. You just have to be on a terminal. And so literally all you have to do for Mac is just type in what they give us, and it will install using the Anaconda environment. If for some reason you're not using Anaconda, then of course you'd want to use pip and all of that. And if you have trouble, we can talk about it and work through it. But that's all you have to do to get it going. Now, after you get it running, or after you get it installed, I should say, you can do a Marimo tutorial intro, and it will start up your browser and start a pre-canned page and all of this for you to work through. Okay. All right. And so this is what it looks like. It's much the same as Jupyter in many respects, most respects, actually. There's still a run button up there in case you change something in running. It still runs with a shift enter, et cetera. I'll let you guys go through. Well, should I go through the intro? You know, I mean, this tutorial now, or should I let you guys do it? Opinions?
Can you explain maybe like loading data? I mean, I don't know. How long is this intro?
Mm, not
Do
very
you think
long.
it's worth it?
Probably is, yeah. I can go
Okay,
through it.
that
So,
sounds good.
as we were saying, um, it has built-in GUI widgets. So, if you have you know, something like this UI.slider, then it should give you something like that.
That's pretty cool.
Yeah. Right. That's really cool. So you can see, you know, here's the code behind that. Right. So all it does is literally does, you know, slider.value to make that work. So it's really easy to get going. Let's see. So here's an accordion. Where'd that go? Someplace it is. So it's one of these things that does that. So it talks then about reactive execution, small blocks of cells, they automatically run. This can be changed, this behavior of automatically running, and it also automatically runs the notebook when you load it. It doesn't store values the way that Jupyter does. It runs everything when you load it, which can be problematic for really long running notebooks or cells. And you can turn that off. I'd like, for the most part, for us to keep that on. But, you know, we can discuss it. Let's see here. I don't know what was in. You can write markdown in cells, and that's what this MD is right here, because it's writing markdown. So here, we change this to true. Hit enter. It was supposed to change something else too. I've already been through this once or twice, so I may have changed things. This I think was supposed to do show that execution, but or the auto running execution, but for some reason it didn't. So moving on.
I don't think that markdown.
I did.
And if you run it, but you just have markdown through.
Oh, about it.
See that page.
Oh, see, yeah, that's neat. Okay, I get it. I get it. So this is, yeah, this is actually in the markdown, and it changed the value. So you can programmatically put stuff in your markdown comments. Just kind of neat. If you read this about execution order, second. Hey, Matt, can you close that? Thanks. It talks about execution order here, and it's a little bit weird. It kind of figures out the execution order for you, So you can move cells up and down, back and forth, and it will figure out the right place to run them. And so now we no longer have that thing where, you're halfway down the notebook page and, you write something, in your data frame, and you would normally want it to run, back up here, but it's actually down here, and none of that anymore. If you want to take all of your function declaration cells and stick them at the bottom, you can do it. If you want to put all your imports at the bottom, you can do it. And it'll figure out the right way to run it. And the one thing that's probably going to be the biggest change for everybody is that global names are unique. And so what that means is this variable here changed. That is a global variable, and we cannot like reassign it to, something like a list, right? It's already a Boolean type, so changing it true false is okay, but I couldn't reassign it to like a new list or a new dictionary or a new data frame. It would throw an error. And I think it actually shows that here someplace, somewhere. At some point. Let's see. Encapsulating in cells. Okay, we'll write it down. And private variables. If you don't want your variable to be global, you can put an underscore in the front of it. And that makes it private to that cell. So in other words, its scope is the cell. And then you can reuse it someplace else. All right. Then there's UI elements. And so here we've got, some of this stuff. UI elements with little things. And so here, the icon is, I drop down in repetitions is a slider. So we can change, which one of these things it is. And it changes, both of those. And so on and so forth. Lots of stuff that you can do. That's what I should have done one more cell. Let's see, this next section, Mermo is just Python. This is just telling us that the Mermo notebook files are actually just python.py files. And if you open one in a regular notebook or regular editor, you'll see that it has special tags, special decorators for each cell. And it's got comments at the top that say it's a Mermo notebook. So you couldn't just slip a normal Python file in and expect it to be right. And when I'm grading these things, you can't just give me something, cut and pasted from ChatGPT that's a regular old Python file. I'll know immediately. Let's see, notebooks can be run as apps. So if you've got like a dashboard or something like that, you can run it as an app instead of as a notebook. And then we've got some command line tools. So this is to run a notebook like an app. Mermo Edit is how you get it started in a browser. And again, this is all command line stuff. I would hope, most people past 650 or 610 should at least know how to get to their terminal window. Tonight's other lecture is is a byproduct of this convert right here. I took a Jupyter notebook. It was a normal lecture notebook and did the conversion on it. Seemed to work really well too. And then there's a whole variety of other tutorials that you can do. So you can see tutorial data flow and so on and so forth. Another one that should be interesting for a lot of us is how to use SQL. If you install the full package, the full recommended package, it will also install DuckDB, and it integrates very tightly with DuckDB. So what that means is you can literally write SQL queries as Python in your cells and get the results back and put them in a data frame very, very easily. And I will admit, I haven't tried that yet. That's secondhand to me. I still have to try it. There's more things here that talks about savings automatic, talked about running. Most things, it's kind of the same. You can, grab onto this thing and move cells around. Here's the run button if you need it. Here's the throwaway button. There's a context menu over here that does a whole bunch of neat stuff, including changing the cell types or do formatting, et cetera, et cetera. You can even do neat things like tell it to hide the code or something like that if you need to. And then I'm really intrigued also by over here, present as, and I can have it present as slides. And I tried that a little earlier with the regular lecture notebook, and it worked okay. It wasn't exactly formatted correctly, so I probably won't do that tonight, but I probably will for the rest of the lectures. They'll make it flow a little bit better. But anyway, and on that note, then there's also the configuration here and then some other user settings. I actually like that on full, but it kind of doesn't matter. And you can automatically export your outputs to either a Python, a Jupyter notebook, or to HTML, which is kind of neat. So that's about as much as I know about it so far. There's a whole lot more here that I haven't found. Actually, over here is tools also, so you can look at your files. You can look at your variables. You can explore data sources, which honestly means your databases. Install packages, AI. There's a little scratch pad you can run some Python if you don't know what it's going to do, or you need to experiment. You can do it over here on the scratch pad. There's a whole library of snippets, and you can add your own. I haven't gotten around to it yet, but it looks really good. So you click one of these, and it gives you an explanation, and it gives you the code down below that you can cut and paste out of. So, and there's quite a few of those also. A couple pages, including some pandas stuff, some matplotlib stuff. Let's see. You can view docs. So when you have this turned on, it will show more like tooltips stuff, help from the documentation. Those are the most useful ones there. Any questions on this? anybody lost.
Is that like, a workspace concept? Like if I'm in the folder,
Uh,
do I have to specify the file that I want to be working with when I launch?
yeah, so,
Or can I just launch it and then go open that file?
you can do a Marimo edit and the file name, and it'll just give you the file.
Yeah, I saw that, and I was seeing if there was any other options.
So, yeah, there is. I'll show you here in a second.
Okay.
Specifically, are there any questions about this tutorial notebook that we went through? Well, no, I just want to do that before I go off and start doing other stuff. That's all.
Yeah.
All right. If I don't hear anything, then that means no. So I'm going to quit this. Do that. And then go back here. If for some reason your browser doesn't load, you can always take this URL and stick that in your browser, and it'll start up, whatever you're doing. So I'm in this MSDE621 week 1 folder, which has, as you can see, my notebooks, Jupyter notebooks, and the conversions to the Jupyter, Python file that Marimo reads. And so if I start here, just Marimo edit with nothing else, then it starts me off, and you can see here the workspaces,
Oh, yeah.
right? And then whenever you click one of these, then it opens a new tab for you. Um, So yeah, I was really disturbed that we're thinking that there's no equivalent to like Jupyter Labs or something like that. And I think this is their answer to that. All right, so if there's no questions, then I'll start off with tonight's regularly scheduled lecture. Just like 620, this kind of goes back to the beginning and goes through some of the basics of Python. I'm sorry if that's a little boring for some people, but I also know that some people kind of need that review. So hopefully it'll be most useful for most people. A lot of the ideas for this notebook were taken out of this Data Wrangling with Python book. It's a good book. It's way out of date. It's still Python 2.7. And I haven't seen an update to it. So good concept, bad code. And you can get it, of course, at Amazon. I'll give you the ISBNs in case you want to look it up and see if there's anything new. Let's see. Any of the code that's in the book you can find on the author's GitHub site. I'm not going to go to. All right. So tonight we'll talk about some Python basics. We'll look at data structures and lists, dictionaries. We'll do some stuff working with files. And then we're going to work on reading CSV files by hand. So not using any libraries or anything like that. How to do it manually, how to convert it to JSON manually, and how to convert it back to CSV manually. I understand that there are tools to do this. This is an exercise in programming and how to think on your feet with different file formats more than anything else. Because there are some places where you get in there and they don't let you, pip install new libraries. or things like that. Pandas, of course, will read both of those formats, but pandas is a hog of memory. And, you know, it would be pretty wasteful to load pandas just to do a CSV to JSON conversion. I've seen people do that. All right, so Python, high level language. It's interpreted with a kind of a bytecode compiler on the back end. It's single threaded, although I guess the new 3.14 release has the global interpreter lock turned off, and you can turn it off and have multi-threaded Python. It's very exciting. The two primary data structures that we see are the lists and dictionaries. And my attempt at humor here, an array by any other name that smells sweet, yeah, okay. Laugh or don't. But let's say we have a variable int with a list in it with 10 integers. So range 0 to 10, which gives you 0 to 9, which is 10 numbers. That's not confusing at all, right? Okay, so there we go. Exactly what we expect. First element is always a 0, as you would expect. It's kind of unfortunate that the 0 element is also the number 0. There's no magic there. Let's see. We know about len. We can ask for the length of things. We can take slices. And unfortunately, I don't think they're printing anything out. Oh, yeah. And then you can reverse your slice with a -1 in the fourth position. That works for strings as well, also. See, the len function always tells you the length of whatever data structure you're working with. We can reverse our integers that way. Let's see. Okay, so this is a concept. Some people that are new to programming have trouble with loops. And so I threw this little bit in here. Many languages have the concept of a for each loop. And that's what Python is, even though they don't say for each. If you think of it as for each item in a container, then you would do actions on that item that you get out of the container. Right. So you can also use the enumerate function to get an index along with your for loop. So in some languages, C++ or Java, you'll see people do, I is 0 above the loop, and then I plus plus or I plus equals 1 or something down in the loop. You don't have to do that here. You can use that enumerate function. So like this. So here we're enumerating our integers and getting the index number out with it. Basic stuff I know. Okay, dictionaries. Dictionaries are the other main type of data structure that you'll see in Python. There's other ones too, but these are the two main ones. A dictionary is sometimes called an associative array. So you'll associate a key to a value. And so in this case, the thing on the left-hand side of the colon is the key. The thing on the right side is the value. Dictionaries, you can mix with different types in Python. Most languages you can't. And also be aware that the value can be either a dictionary or a list. So there's our roots. Let's see, keys are used just like the indices of an array. As you expect. So now, where life gets really interesting is when the value is another data structure. So in this case, I just set weight to be a list. And now we have that list. And if you look at, so the way to get to any particular value in this list is you use two square brackets. So for the weight key, I want the 1th item. And so I have to use 2 sets of square brackets. The key to all of this is keeping track of what the thing in the square brackets is talking to, right? Keep track of what the item is in the container. In other words, in this case, weight is now a list. So you put weight where you get the entire list. Then to choose one item out of that list, you have to subscript to that as well. Like so. And the entire thing looks like this. Looks like the Marimo is kind of neat, and it's actually formatting this data structure for us, which is nice. I'll show you another way to do it later on in this notebook. Dictionary keys don't have to be strings, but the fact that they can be strings is very powerful, because now you have something descriptive. That key can be descriptive of what your value is or what it represents. It's also worth noting that JSON format is essentially a Python dictionary. We'll look at that soon. Any questions so far? I would expect it, but just in case. Have we talked about lists of dictionaries in any of our classes? It's really popular data structure to have a list, and each element in the list is a dictionary. So here, if I have this variable SC1, which is a dictionary, as you can see, and then I've got SC2, which is another dictionary. I can put both of those dictionaries into a list, like so. And if you look at it, you can clearly see where one dictionary begins and the other ends. So in case you ever can't tell exactly what your type of variable you're looking at, you can always use the type function. So in this case, we ask it what scientist is, and it's a list. And if you ask scientists for length, you get 2, because it's 2 dictionaries. Yeah, 2. And so just like above where we got to the 1th element of the list in a dictionary by multiple subscripts, you do the same thing here to get to each item in each dictionary in the list. So the 0th element in here is this SC1. Okay. So when you subscript it with just a 0, you get that entire dictionary back. And since its subscript returns the dictionary, if you do a blend of that, now you get 5 instead of just 1. And you can verify that it's a dictionary by asking, what are you? It tells us dictionary. Okay, so this, if you remember your Python theory here, keys in dictionaries have to be unique. And so I cannot have a dictionary with two keys that say name. So if I'm trying to make a dictionary where I'm trying to save the information from several people, this is how you have to do it. Because you can't do it just with one dictionary. Unless you really have a lot of spare time on your hands and you want to say name one, name two, name three, etc. I wouldn't recommend it. And so that's what this is really useful for. A lot of times we try to keep related data together. That's what a dictionary is for. But if you have multiple instances of related data with the same, types of data repeated, the only way to store it in a container is with a list of dictionaries. That's why I'm showing you this. So now, if I want to get to the name element in the first dictionary, as I said, it's multiple subscripts. And in the other dictionary, like that. And I say this is really useful. There's several libraries in the Python package index that deal with working with dictionaries and lists in this format to make it look easier to deal with. I think we actually even use one of them later on in one of the assignments, but we'll burn that bridge when we get to it. Okay, so that's data structures. Any questions on that part? Okay, all right, files. Now this is one of my little soapboxes, okay? When you're working with files, you have to know the location. And by location, I mean the location on your hard drive. Each operating system has an organization to how it keeps its files. It's usually some sort of a tree structure. Mac and Linux have one way of doing it. Windows has another, you can call it that. And you need to know how to navigate that directory structure in order to get to your files. It's just a basic piece of working with a computer on our level that you have to know a command line, you have to know how to change directories on a command line, you have to know how to find other directories, all of that kind of thing. And in order to do that, you've got to know this, file structure. All right, so we're going to work with a simple text file. I got it from this norvig.com. Peter Norvig is he's a Microsoft artificial intelligence researcher. And he and another guy, I forgot the name, wrote one of the seminal, most quoted books on artificial intelligence. It's about 4 inches thick and really hard to read. But he had this Shakespeare About Text, which is the full works of Shakespeare. If you want to download it, you can. I have it here. I don't remember if it's I think it's the full thing. And that reminds me, to delete this file. I'm not going to open it because if it is the full works of Shakespeare, it's several 100,000 lines long. I'm going to do that. Okay, so there's a couple of different ways to deal with files. In Python, there's multiple ways of doing everything, and you pretty much just have to figure out your favorite way and stick to it. Starting with Python, I think 3.6, they introduced this idea called a context manager. A context manager is means that everything under a keyword, in this case with, everything under that with is indented and it belongs in a group. And as soon as you go out of the scope of that group, then files are closed, variables are released, all of those kinds of things. Database connections are closed. And it's a really convenient way of working with files. There is an older way to do it. I'll show you how to do that. One interesting fact with these Merrill notebooks, you can no longer do this exclamation point and a shell command, and they will not change that because it's not standard Python. And everything that's in a notebook has to be standard Python. There's ways to get around that. You can call a shell library and do like a subshell and get it done. We might look at that later, but I'm not going to right now. Which means that this won't run, even if I put the exclamation mark in front of it. See, it won't run. So that's one downside of working with the minimal notebooks. But considering that you've got, your files over here, I don't know how necessary it is really anymore to be able to do that. Okay, so I'm going to take my Shakespeare file. That's going to be my data file. The flag is going to be set for reading. That's the R here. There's some other ones. There's read and write. There's write only. There's append and read, yada, yada. Okay. There's some interesting caveats here. If you do write only and the file already exists, it erases the file. In most cases, append is what you want. Or append and read is what you want for the most flexibility. All right, so here, with is the context manager. The command is the open. In file in this case is a pointer. It's a file pointer that points to this file on the disk. And that's our handle that we use in the context. So from there, we've got a for loop. And by default, a for loop like this will read lines out of the file. So that's what we're going to do. And we'll append each line to this file lines list. And it should be fairly fast. 129,107 lines. The older format that you still see on Stack Overflow in some places is like this, where it'll put the file handle over here and have the open with no width. And the problem with this is it doesn't close the file when it's done, which can potentially lead to some data loss if the program or the notebook stops execution abruptly. And so I'm not gonna mess with it. It's there kind of for archival purposes. I suggest always going with the context manager. So then let's talk about enumerating. We saw enumerate up above. So here is my counter variable, and that's the item variable. And that's my container, and we're enumerating to get numbers with the items. So here I'm just going to print the first 10 lines. So I'm saying, if C is less than 10, then print the line, otherwise break, which means exit the loop. Like so. That's a really contrived example that's there mostly just to show how the enumerate works. Most of the time, you'll probably want to do that kind of thing with a slice. Like so. So, that's indexing multiple elements out of an array, if you need to know it. Right. Now, one interesting thing here is when we print like this up here, notice how there's there's like a blank line break in there. That's because it is giving us the end of line character that's in file as well. Whereas here, it's represented as the space, but it's not actually printing. There's probably a way in Narrow Mode to actually show that. I need to look it up. But that's what's going on. And so it's very rare that we would actually want that on our string. So we need to strip it off. And we can do that with the strip function. So if we do that, notice how now I took that extra space looking thing off of there. That was the end of line. So you can treat strings as if they were arrays or lists. A string is just a list of characters. And so it's subject to the same slicing syntax as any other list is. And as I said earlier, you can print a string backwards with indexing. Okay, questions? Should be pretty much reviewed for everybody, I hope. Now, here's where we're going to get a little bit more interesting. CSVs by hand. So obviously CSV, comma separated value, we work with those all the time. We're going to work with the scientist.csv, which you can see here. Narrow Mode tries to be nice to us and gives it to us in columns. And that's fine. If you open that in a regular text editor, you'll see it's, just commas between each one, like we sort of expect. There's probably a way to turn that off, that behavior off, but I don't know what it does offhand. So if we read it in like a text file, as we did earlier, that's what it looks like. And so it reads it in as one string with an end of line on the end of it. Okay, right. And that's because it's giving you line by line that read the line as a chunk, and that line included a new line character, which is why there's multiple lines in file. So way you would split that up is with the split function. And so if we want to split that header up, that's line 0. And that's more like what we're expecting. We still have that end of line character on the back there, though. So header is 5 elements, which means 0 to 4. And so if we look at element 4, there's occupation, and there's that end of line character on the end of it. So if we wanted to correct that programmatically, we could do it with the length of header -1 to give you the number of the last element. And then you strip on that, and that takes it off. We can do that all in one step by putting a strip inside with the split. Because strip by default only takes white space type characters, so spaces, tabs, new lines, whatever. it won't actually take characters off unless you tell it to. And so it'll read in line by line, it will script that into off the line, and then I'll send it into split to split it up. And then you can see, yeah, it's not there. Okay, so now we have our CSV and we want to change it into JSON. JSON, if you don't know, is JavaScript object notation. It's a very popular method for moving data around on the web. Several databases, document databases like MongoDB, store JSON internally. Well, it's JSON is binary, but that's the sort of thing. And so it is common that you'll do like a query to a MongoDB database and get JSON back. You need to know how to deal with that, especially if you're going to stick it into something like pandas. You need to know how to convert it into CSV format so pandas can read it. You don't have to. Pandas, I think, can understand JSON also, but just go with me for that moment. Okay. So yeah, kind of the most direct way to make a dictionary out of a couple of lists is with zip function. Zip will take two similarly sized arrays or lists and put them together. So we'll zip those two lists and then we'll force it into a dictionary, which gives us the format that we want. Like so. Something. Right, so problem that we have is each one of our lines from the CSV file is still one big long string. So we got to do something with that. Fortunately, we figured out that we can split like so. So hopefully you'll understand where we're going with this, right? We've got our container scientists, and for each item in that CSV text variable, we'll use split and split it into individual items, and then we'll zip it with the header and store it into a list. Something along those lines. Right. And so that's what that looks like. And so there is our list of dictionaries, as we talked about earlier. So if you want to print each scientist's name, you can, iterate through the list and do a print like so. Or something like that. So we're still in the range of code that I think everybody should be able to write by the time they get to this class, without too much in the way of reference. You should be able to do all of these things without having to ask ChatGPT or Stack Overflow how to do it. Hopefully. Now, I said that doing it manually is kind of the caveman way. There are CSV libraries. So the most common that we would look at, of course, is CSV. You still have to open the file, but here now we use a CSV reader object. And since it's CSV, the CSV reader object is smart enough to know to break it up and to take the new lines off and all of those things that we want to happen. So now the next step is when it reads each line, stick it into a dictionary. To do that, we would use ordered dict, which means it's an ordered dictionary. And the object we use is dict reader. So what's really going on is dict reader puts things in ordered dictionary format, and we just have to know that to deal with it. The reason for that is historically, dictionaries were an unordered data container. It was only about Python 3.7 or so that dictionaries became guaranteed to be ordered in the order that you load the data. So if we do that now, you can see it gave us dictionaries as output. So we can use the pretty print module to make that look a little bit nicer. So when it prints out, we just call it the pprint function. In general, in programming, if you're trying to format something like this, you call it pretty printing, and so that's what this is showing us. We can convert the ordered dictionary to a regular dictionary and pretty print it. So that's what this right here is doing, is it's converting that ordered dictionary that comes out of dict reader to a regular dictionary. So dict reader is smart enough to understand that it needs to read each line in the CSV and associate the data with the header row. You can also, tell it that there's no header or something like that. You can also ask it what are the names in the file, of the header, and it'll tell you. There's a whole bunch of other stuff that you can do. You can, of course, go look at the Python docs to find out more about CSV library. Okay, everybody knows what pandas is. You've already done all this. Pandas, data frames, yada yada. Now, JSON. There's a couple of different JSON libraries out there. The kind of standard one that comes with Python and install is just general JSON. This library is pretty slow, and there's other faster versions out there, but this is the one that you don't have to install. So that's the one to look at. Oops, I guess we have to do those lines. So we're going to do that. Oh, here we go. Right, so Pandas knows how to put things into a JSON format. And it does some really funky thing where it tries to tries to reorient the records. It's really weird. The way it does it. So in order to make the dictionaries look, what we want to come out of a data frame is where each row is a dictionary with the column names as the keys. The way to get the to.json function to do that is to tell it to orient on records. Otherwise, it does some weird thing where it orients on the index and jumbles it up. It's really weird. So what that does is it gives us a string, which is okay if you're going to send it to a file, but it's kind of not so okay if you want to put it to the screen. So you can use the JSON load S function, and that says to load a string and put it into JSON format. And then PrettyPrint is smart enough to know how to print JSON. And it looks good if you give it a little bit of indent. So let's recap for a second. We started off with a pandas data frame of our scientists. We used the to.json function to put it into a stringified version of JSON. We use this load_s function to read the JSON string and make it actual JSON, which is a dictionary. And then we use preprint to print it to the screen in dictionary format. Okay. So, this is a little function I found a few years ago. It's a little bit better version of PrettyPrint for dictionaries and lists and things. The problem with the straight up PrettyPrint is it doesn't do nested things very well. So if one of your dictionary values is a list, it won't handle the list elements very well. And this will do a better job of it. So remember, this is the stringified version of the JSON, and there it prints nicely in dictionary format for us. Okay, so what do you do about JSON without pandas? So remember, I said pandas is really overkill just to read a JSON file or a CSV file or something like that. So if we want to work with that directly, there's a little function that will open the CSV, it'll read the lines in as dictionaries. And then it will open a new file with the JSON format and dump those rows back out in JSON format. And so if we look over here, I don't have that file there. Why did you not do that? Oh, wait, yeah, okay, there it is. So here's our file. We can look at it. So there it is in JSON format. So that's what this little bit of code did here. It read it in CSV format and outputted it in JSON format. Now to prove that that works, we can open this file and use JSON.load to load the JSON and print out what we get from it. And you can see that's that. The reason I did this, is, in case we don't get it, is data is a new variable that's never been associated to anything else. And so when I do this load, it's taking the stuff out of this new file, sticking it into a new variable. And when we print the variable, we see that it has the data in it that we want. So that's proof that it worked. We can parameterize what we did above. So, set your file name into a variable and use that in the with open, for example. All right. So, any questions with any of that? This should give you an idea of where we're going with this class. If MSDS620 is how to manipulate data with pandas, this class is how to manipulate data that doesn't fit in pandas, ideally making it fit into pandas at the end of manipulation. That's a little bit hard to write as the title to a class, so we just call it data wrangling. As we go through the class, we're going to do some interesting things like take data out of Excel spreadsheets and put it into MongoDB, or document database, moving up Mongo. We'll read position delimited data files from the CDC by getting the positions out of PDFs. We will scrape websites to prove who's better baseball, Japanese baseball players or American, and a couple of other things. So that's where we're headed. Tonight was sort of a warm-up in case you need a little bit of a reminder of how Python works. Now, here's where things get interesting because I don't know how to do this yet. We're going to look at the assignment. It's a really pretty easy assignment. I would expect you don't have to use AI for this. But in case you wanted to, what I want to do is I want to let people go ahead and use AI to write this if they want, but I want the prompt that you use to do it with. Later on, we'll do that same kind of thing, but I'll have you do more analysis after you're done with the AI part. This is a little bit too simplistic for that. So I'm not going to require anybody to use AI if you don't want to, but I think it's a good idea for us to get used to it. And I will admit, I haven't used it to write a hell of a lot of code myself. So this is a learning process for me too. In the class lecture, we saw this little bit of code that took a CSV file and stuck it in JSON format. With that thought in mind, I've got a couple things to do. So the first is I want you to look up in Wikipedia eager evaluation and lazy evaluation, and answer these 3 questions down here based on what you read out of those definitions. This is particularly relevant to what we're doing right now because Jupyter notebooks are lazy evaluation, whereas Marimo by default is eager evaluation. And that's what this on startup lazy or eager means right down here. And so if you've never been exposed to those terms, is something in the industry that you need to know what it is. So that's one part. It's okay to write it in Markdown in your notebook. I would prefer it like that, actually. Part two is this idea up here, we did this conversion operation for a file, a specifically named file in a specific path. And if you are any kind of data scientist or software engineer, you'll look at that and you'll say, so what? You can do it once. Okay. I'm not interested in doing it once. I'm interested in doing it 1,000 times. I'm interested in doing it every single time I need it without having to change the code, right? What that means is I want a function. I want to abstract this functionality, stick it into a function so that I can just call the function and have it do the work for me every time. Okay. As I say, that's a process called abstraction, and that's the way that computer scientists think. If I'm going to use this more than once, I want it in a function. So I want you to abstract that process up above into a generalized CSV to JSON and JSON to CSV function. Right? So we did one direction, CSV to JSON. You're going to do JSON to CSV. And then to prove that it's correct, I want you to take a CSV file and go CSV to JSON back to CSV or JSON to CSV back to JSON. And it should be the same coming out as it went in. It would be nice if there's an intermediate print in there someplace so we can see it actually brings into that intermediate format. But we can work on that. So, like I say, this is a little bit too simplistic to do something, like analysis with the output of the AI. So, feel free to use the AI to write the code, write parts of it, make it better, whatever you want. But if you do use AI, I want the prompt that you did it with, and preferably the LLM that you did it with too. So ChatGPT or Claude or whomever. I do not have that written into this notebook yet, because honestly, this is changing as I say it. But I'll get that written in tonight and upload it to the website in world class. I will also upload my .py versions of these notebooks so you can run them in Marrow. Because up on world class, all we have is the Jupyter notebook versions. Make sense? Anybody have any questions? Anybody have any comments? Open to those too.
I'll say that markdown is pretty cool. Like I was doing the Python demo.md, and then I noticed that there's actually a little markdown thing, and it converts it all to Python. Pretty slick.
Yeah, it is. They definitely, when they were writing these notebooks, they took all the bad parts of Jupyter and said, we want to fix this. So it's very impressive. All right, any other comments or questions? Let's see, I would like for assignments to do on ideally Tuesday night. That way I've got Wednesday to grade, I hope. And then we can talk about whatever happens then on Thursday. Yeah, that's about it. I think deadline to have everything in at the end of the class is December 14th at midnight. My last classes that just finished, I had a few people that didn't understand that concept. I had people turning things in at 11:59 on Wednesday. Those of you that have had class with me in the past, know that I used to have a pretty liberal attitude towards reworking things and towards late submissions, based on how people have been abusing that policy, we're going to be making some changes. Especially since we're using AI to do some of the work. I don't really want to accept anything late. So we can talk about that as it happens, but this stuff that I had happen last semester or last session where people like handed in 8 weeks worth of assignments on, the last week. That isn't going to happen again. So, yes, as so often happens in life, 2 or 3 people screwed it up for everybody else. Sorry. So now any questions?
Discussion.
Yeah, sure.
Or-
Oh, yeah. Right, discussions. You know what? We're not even gonna do discussions. I'm gonna delete them. I hated him as a student. I hate him as an instructor. You guys hate him. I'm just not gonna do it. So don't even worry about it. Other questions?
This is not right, there's only 2 of us in class.
Could be.
What was
Yeah,
that comment?
there's only 2
There's a
and
few of that, Grace.
There's only 2 people in the class and then me.
2 people, there's only 2 people attending.
yeah,
Oh, total.
yeah. I guess everybody else is gonna watch the recording. So
How many people are signed up?
there's actually like, I don't know, 10, 12, something like that.
Oh, okay.
I was looking at it earlier. There's a few. Yeah. 9, I guess. So it was 11, and one of them was me, and one of them was the demo student, so it would be 9. All right, I'm gonna kill the recording.